Hey there, everybody. Sorry, I started the stream, but I forgot that it wasn't live yet. So we're going to do a countdown so we can make sure that everybody gets into the stream. All right, so here we go. All right. Hopefully that was enough to give you all a little bit of a time to get into the stream. I see there's 16 friends out there live, so welcome everybody, and hope you enjoy this this program. How is everybody doing? Hi there, Zelkova Tree. How are you? Hope you're doing well. Awesome. Good to see you. Welcome back into the stream. Oh, I'm not sure how to get rid of this banner, actually. Oh, there we go. Not so bad. Hey there, Hiki. How are you? I'm doing good. Just this is our second stream of the day, so pretty excited for that. And Jagar as well. Hope you're doing good. So yeah, let me go ahead and introduce the stream for today. So we're going to be doing Introduction to Kubernetes Part 1. Okay. And so because it's Part 1, we're going to really take you from zero to hero today. All right. So first, I want to just acknowledge that I am your coach. My name is Steven. I've been hacking for almost 10 years now, and I'm super excited for this Global Hack Week, Cloud Week, and to just be hanging out with all of you. So before we get started, really important that you actually check in for this event. So I'm going to be typing it into the chat here. Oh, awesome. Hiki says, it's my first MLH stream. I've been wanting to learn Kubernetes for a while. That's great. And if you want to give us some feedback on Global Hack Week, please feel free so you can see more events like this. Yeah, this is sort of a new thing we're trying is getting some more feedback from all of you. So if it's your first stream, just let us know what you think of the programming that we have for you. All right. So this check-in link is really important because it helps us in two ways. The first way is that it really helps us understand the kind of content you're interested in. I mean, if a stream is really popular, we'll see a lot of check-ins, and we might make more content like that. And on the other hand, if the stream doesn't get that many check-ins, and we thought it might, we'll probably reconsider why that happened and try to improve for you. Oh, Hiki says, do you post records of the stream? It's 4 a.m. here. My goodness, that's pretty late or early, depending on what side of the bed you are on. But we do. So I'll actually send the link in the chat right now to our YouTube channel, which is where we post all of our streams. Okay, so you should be able to see that below. And yeah, let's continue on now. And yeah, no problem. Thanks for joining. You're the best for joining at 4 a.m. My goodness. And I will catch you on the recording. All right. So why don't we continue along with our goals for today? And we have a few. So we're going to talk about the Kubernetes components, okay? And you're going to get really comfortable with these, which include pods, nodes, deployments, replica sets, and services. And we'll even dive into a few things called config maps, secrets and probes. We might not get to all of these components today, but we certainly will someday soon, because we have parts 2 and 3 coming up after this. Bunit says hello. Hi there. Hope you're doing well. Okay, so the second thing we have in store for the day is writing and modifying YAML files. So has anyone here heard of a YAML file? Anybody in the chat? All right, no answers in the chat, but that's okay. We can go over YAML files today. Hiki says yes, but I've never known their use. So we can talk about them today. We're gonna learn how to use them. Jagar says yes, but I don't know what they are. So we're going to talk about them today. They're really useful for our deployments, services, and configuring our Kubernetes clusters. So that'll be really good. And then we'll also get some hands-on practice with Kubernetes. Okay, so that'll be another good thing to do. And we'll learn to add environment variables, resource limits, health probes, and auto scaling to Kubernetes. Now, we're not going to, we're not going to probably get to all of this stuff today, but these are some of our goals, maybe our reach goals. And if we miss anything, we always can touch on it in part 2. Okay, so let's go ahead and get to our next slide, which is a welcome slide. And I guess a lot of you have given some of your experience levels already. But if you were to rate your Kubernetes experience, maybe in the chat you can say whether you're a beginner, you would say intermediate or advanced. And then I want you to describe this word. And you may have heard it before or you may not have, but it's called orchestration. And I want you to describe that word to me and tell me what you think, what comes to your mind when you hear that word. All right, so we're gonna talk about that. So quite a few people saying beginner, even I've never used them. So it sounds like we're in the right place for part 1. And then Kitsune says, orchestration is a lot like Moonlight Sonata. I'm assuming you mean like some sort of orchestra performance. And in a way, that's exactly what it would be, right? So, just thinking about that for a minute, an orchestra has a bunch of members who are all playing together, working towards some common goal, right? So that's a lot like what we're seeing with our Kubernetes containers, where they can be managed towards the common goal of feeding your clients what they want to see. So that's our poll. And here's another example here. It's managing different instances of the application. That's right. And control different tools. Yeah, so you want to make sure all those tools are working together, not working against each other. So those are some really great answers from all of you. All right, and so now we're going to actually do a few of these lecture slides. We won't do too many because I want to get you all up and running with your Kubernetes, but we want to just understand a few things first. So first, I want to just give an overview of what is Kubernetes, since many of you said that you don't ever have any experience using this actually. So it's an open source platform. So that means that it's developed freely on the internet, designed to automate the process for deploying, scaling, and operating application containers. And if you're unfamiliar with what a container is, it's sort of an environment in which your code can run. And the container is great because it has a certain operating system, a certain Python distribution or JavaScript distribution or whatever language you're using, and it has all the dependencies lined up. So it's even better than, let's say, a Conda environment where you have all your dependencies listed. A container is actually everything all the way down to the OS level is going to be contained or containerized within a certain application container. And so these Kubernetes platform could be thought of as a system that manages these containers, okay? And as it says here, it's like a lightweight portable unit that packages up your application along with everything it needs to run, okay? So that's what we can think of for Kubernetes. And containers are a way to package your code and its dependencies together. They allow you to run your applications reliably when you're moving from one computer environment to another. So you might have asked yourself, hey, why do I need this? Why do I need to know, about where, okay, all of my Python versions are this way, or, all of my, you know, dependencies are that way. The reason is because you might want to sometimes move from one server to another. Maybe your server needs maintenance, but you don't want to take your application offline. Okay, that could be a great reason why. So that's why we containerize our code. And then orchestration, this is that question I asked you all before. It refers to managing these containers automatically. Okay, so Kubernetes is going to do this by ensuring that you run the right number for your load, automatically scale up and down based on demand, and handle updates without any downtime. Okay, and we do have a request to share our slides. So let's try and I'm going to try and get those for you. Let's see. I'm gonna get those for you. Just give me 1 minute to get that going. And I'll share this so that anyone can view it if they have this link. Yeah, looks so these are good comments here. It doesn't work on my application problem. Yeah, or on my machine problem. That's the problem we're trying to solve with containers. On a professional level, really. And then, yeah, no problem, Sandra. So just for everyone else's benefit, here is the link for today's slides. You can actually see what we're going to cover. And we may have some time at the end, in which case we will review some of our serverless. We didn't get to do all of our serverless stream earlier today. So if we do have extra time, we can go through that, but we may not either. So the tools you'll need, this is really the first thing we're going to do, is you're first going to need to get the command line tool, which we call kubectl or kubectl. And you can get that in the following docs. So let's actually try to install. So I'll show you what you're going to need. So I just visited this website, and you can see that you can download kubectl or kubectl, whatever you want to call it, on your platform. So mine is Mac OS. So remember, you must use a kubectl version when there's one minor version difference of your cluster. So that's true. So we want we want to make sure we download the latest things here so that we get it all. And yeah, we can. I'm actually on Apple Silicon, not Intel based. So let's try to copy this code, and we'll go into our terminal. Okay. A lot of stuff from our previous stream where we did serverless computing. you can see there's a lot here. But I'm just going to make a directory for us, and I'll call this Kubernetes. Go into there, and I'm going to paste that command that I got from the website. It's a curl command, so it's going to download this. And you can see that the download was successful. So it got that downloaded. And now that it's downloaded, we can actually validate this. So we'll download the kubectl checksum file, which is a way to validate. So I'll show you how to do that. It's step number 2 here, and you probably have it on your machine as well. So you copy that, and we will paste that into our terminal. And we'll hit enter. And so that's our checksum. And so we can validate the kubectl binary against the checksum file. And it should, if we write this as it should say, it should give us OK. So we see that output there, right? kubectl OK. So you should see this as well. Let me know if you see OK. Okay. Andrew Ty says it says failed. How to do the SHA-SUM thing? Okay. So yeah, what you want to do is make sure you download this properly for your machine. That could be the problem. So try to download the right version for you. So let me just quickly go over this here. Are you on a Windows machine, Sandra, or a Mac machine? Apple Silicon. Okay. So when you go to Mac OS, install kubectl on Mac OS, you want to make sure you've hit the Apple Silicon and copy this command here, this lower one, not the upper one. Oh, actually, I'm sorry, just copy this command up here, number 1. Yep, okay. And then copy this command from Apple Silicon. And it should work. I'm not sure. It could be your internet connection may not be allowing it. Oh, the checksum you want is this one. So just make sure that you have the tab switched to Apple Silicon. Okay. So. Yeah. All right, that's great. Yeah, I'm glad it works. It probably was just the wrong checksum file. So no problem. Yeah, I'm glad that you got that working. That's really good. So, okay. Why don't we continue then? We're going to basically talk about the step 3 here, which is make this kubectl binary executable. Okay, so this is basically what the computer can execute. I'm not sure if this is the same for Mac, actually. I think it is, though. So let's just try it, this command. And it should go in for our terminal. You all can see that. I just type in chmod plus x kubectl. So let's see what happens when we do ls now. So we see our SHA-256, which is going to be that checksum there. And then if we go into this folder, not this folder, but I guess we can't go in. We could look at the file itself using like Vim or something. But let's just keep it this way. So kubectl will be our executable. All right, we'll just keep it like that for now, not go too far down that rabbit hole. Okay, so now we can go back into our notes here, and we're going to move the kubectl binary on your system path. Okay, and so you're going to want to find out what your system path is, and yeah, that's going to be really important for you. So let's go to your terminal to get that going. Okay. Let me open my terminal, and I'll show you how to get to how to find what your path is. Okay. So on Mac, you're going to do echo $path. Okay. So here's my path. Okay. So we want to move onto our path. So this is a pretty long path. Yours might not be looking so complicated. I hope not. Just going to get the exact command here. So it should be on the website. The first thing we'll do is type the following. And you're going to need to provide your system password. Let's see if I can. Okay, so it looks like I remembered my password. That's a good sign, right? When you remember your password, always a good thing. And then we'll make sure that it's an executable. Just we can use this chmod command again. Oh, actually, let's not do that. We'll just do the next step on the website, on the Kubernetes website, which is sudo chown root, and then to do this. And so it should now be in your path environment variable. And to test, so now we're going to go to test. Okay, so let's go back to our website here. To test, to ensure the version you installed is up to date, you're going to have this moment of truth, all right? So this is our moment of truth. We're going to actually try to run a kubectl command, and we're going to use kubectl version -- client. And we could even do it as an output as YAML, but we won't do that yet. So let's just do this first command where we copy this command and we'll put it in our terminal. So now we get our version number, all right? And that's great news for us. It means that everything basically worked exactly as we wanted it to. So good job, everybody, with that. And we're going to just basically keep it moving here. So yeah, why don't we continue along, and we're going to go back to our slides because we've just installed kubectl. And if we go back to our slides here, we also want to install Minikube. All right, and I'm going to show you how to do that next. So Minikube is how we can put local Kubernetes cluster. There's also Kind, which is another option, but I won't be dealing with that one today. Today, we're just going to look at Minikube. And so I'll get you started with that with this link, this same link. It's not the same as before, but let me just paste that into the chat so you can have it. There it is. You should see it now. This is the link to Minikube documentation. So let's take a look. All right. So here we are. Minikube, as I say, quickly sets up a local Kubernetes cluster on your desktop, basically, or your laptop. And so we want to get started here. And hopefully you have these requirements for your computer. And then we're going to do similar thing here with our operating systems. So if you have Mac OS and you have Apple Silicon, you need to do ARM64. If you don't have Silicon, you have Intel processor, you need to do x86 64. And we'll do a binary download, okay? So this is different, obviously, if you're on Windows or Linux. But let's copy this first line here, which is a curl command, the same sort of thing. Oh, sorry, I'm not actually sharing it yet. I'll just share it now. It's not that complicated. Once you visit that site, you should have the link up. And so we'll just copy that first line of code, and we'll get that going. So let's go to our terminal and take that first line of code. And we'll paste it in. All right. Hit enter. So it looks like it's downloading our Minikube now. Minikube is, yeah, it's not quite as big as kubectl, but it's still pretty big. Hi there. How are you today? Welcome to the stream. Yeah, so we're just, if you're getting started here, just getting started, we are doing currently a Minikube installation, okay? So that's what we're currently working on right now. And okay, so the next thing we're going to do is we're going to take a look at Minikube. So let's see if we can just check to install now. So this is our second command. So I'll paste the first command into the chat so that you all have this curl command. You don't have to look at the documentation. But the next command is going to be the installation command. Okay, and it's actually going to be installed on our path. So I'll paste that in the chat as well. And I'm sorry if you don't have sudo permissions. I'm really sorry about that. For this workshop, you are going to need that. You're welcome to follow along, though, if you want. And you can usually also use a virtual machine, which, if you spin up the virtual machine, you have sudo on there. So that's always a hack if you want one. Okay, so now we're going to essentially keep going here by starting our cluster. Okay, we're just going to test that out. But before we do that, I have one last thing that I want you all to install, and that's Visual Studio Code. Okay, so that's our final tool. Okay, so we did command line tool called kubectl. The final tool is our code editor, and that's going to be to edit YAML files. And so you're going to visit this link, which is code.visualstudio.com. I'll paste it in the chat as well. And what you can do with Visual Studio Code is you can use this as a text editor. And remember, a lot of you said, hey, what's a YAML file? I know we are going to use these, but I'm not sure what a YAML file is or how it works. we're going to use Visual Studio Code to help us edit these YAML files, these pesky YAML files. Okay, so for this one, I already have it installed. I pre-installed it because it's a little big. It's not too big, but yeah, it takes a little bit of time to install. So actually, I'm just going to give you all about 1 minute just to install Visual Studio Code. We're just going to give 1 minute in case anybody hasn't already downloaded that. All right, just giving you all that chance to catch up in case you haven't downloaded VS Code. And I'll just show you what it looks like when you actually have it downloaded so that, just so that you have that. So let me share my screen and show you what that would look like if you had it downloaded. So it would open up and it would look something like this. All right, so you can see some of the stuff we've been working on for Global Hack Week. And you would see on the left some panel with your files, and on the center page, you could make a new code or something like that. Okay, so that's what Visual Studio Code looks like. I hope you all were able to download that. If anyone had trouble with any of these downloads, let me know. Let me know because we can pause and we can help you out. Like for example, earlier when we paused to make sure that someone was able to do the checksum for downloading kubectl, we can always do a pause like that. So it's no big deal. That's why we do these things live, actually, and so that you all can get that experience. But now that we've done this, why don't we go ahead and start our cluster? So we're going to do that by using Minikube, and we'll do Minikube start. Okay, and I do have the kind command here too, but we're going to use the Minikube. So let me get my terminal up, and we can hack at it. Okay, where did you go, terminal? There you are. There you are, terminal. All right, so let's see. The first thing we'll type in is Minikube start. And we'll just type that in. Okay. You might have this problem here. Okay, so probably what we need to do is install Docker, which is a container software. I thought I had Docker installed, but I guess not. So this will be good. If you got, did any of you get this message too when you ran yours? We can check to make sure we don't have Docker. Yeah, I forgot about that one. Okay, Sandra, great job. So you had Docker installed before the session. So for anyone who didn't, I guess for whatever reason in this image, I don't have Docker installed. Let's go ahead and install that. So I'll show you what Docker is. On my web browser. Yeah, so if you got that message, it means you don't have Docker installed. So one way you could do that is just to learn how to install Docker. And we should be able to just install the Docker desktop because it has all the things we need. So let's just try to install that on Mac with Apple Silicon. We are not a larger enterprise with 250 employees and 10 million in annual revenue, so we should be fine to not pay that for a subscription. I'm curious though how much a subscription costs. It's not too much really, but yeah, you should be able to get yours for free. So I went ahead and installed Docker. I'm just waiting on that. And Kitsune says, speak for yourself. Yeah, me too. I didn't have it installed on this image. I should have prepped it better for you all, but yeah, so I'm actually going to show you what I'm looking at right now. I'm trying to get this installation going. So I just took the Docker image from the website and I shared that in. So I'll just drag it in, drop it in. Oh wait, stop. I think there should actually, maybe we already have something. Okay, that's a little strange. I'm not gonna lie. So you just drag that in, and then we should have our service agreement in. Install our Docker desktop. You can use your GitHub to sign in and get everything going. All right, so I'll show you what it looks like now that I have everything set up. You can do this too. Just go to the Docker website and get yourself going with Docker. Basically, this is the way that containers are made. Docker is a very popular containerization platform. Okay, so yeah, let me get the Docker link for all of you and throw it in the chat. All right, so hopefully you can get started too with Docker. And let's see if Minikube works now. I'm not sure, it might need to be restarted, but oh, it looks like it's working now. So I'll show you what happens now when I type in Minikube start. I hope yours worked for you, Sandra. Mine seems to be working now. So it auto-selected Docker, downloading all of this Kubernetes stuff, creates the Docker container. You can see it's specifying that it's going to use 2 CPU cores and 4 gigabytes of memory for that container. It's local, of course, so you know, I have more than 2 cores. I have quite a few cores on this laptop, so it shouldn't be a problem to have a container like that. Yeah, you just type Minikube start, as Jager says. Just type Minikube space start, and it should work. Let me know if it doesn't. But yeah, good question. I will put this. I'll put that command in here. Oh no, restart Windows. That's sad. Okay, well, I guess if you want to continue, Kitsune, please, we'll see you in a couple minutes when you restart, or maybe join on your phone, so you can, or the hardest option is to change to Mac in the middle of the stream. But we'll see you in a minute. Yeah, Minikube start would be how you get this to happen. And you can see now kubectl, our Kubernetes is configured to use a Minikube cluster and the default namespace. Okay. Yes, the duality of Microsoft. That's funny. Yeah, I love VS Code, I will say. I used to be a big Windows user. I don't know why I switched to Mac. I just liked how it connected to my iPhone and everything else. I guess. But yeah, so let's just continue along here. And there's one other thing we can do now that we have our cluster running, is that we can actually type kubectl get nodes, okay? And this command lists the nodes and or computers in your Kubernetes cluster. So you should see at least one node listed. And let's try that out. So we're going to type kubectl get nodes. And you can see that we have one node here, Minikube. So it's only 2 minutes old. Imagine being 2 minutes old. That'd be crazy. But it's ready for us, and it's got its version going. So that's great. We have our cluster set up, and the next thing to do is we're going to open our terminal and run kubectl version -- client. That's just so that you can see that we actually should have done this before. I think I probably messed this up, messed up the order of these slides. But that's just to show that you have your kubectl working. Obviously, it's working if we have our kubectl, if our get nodes worked. But now now that we've done some coding, we're gonna go back to our lecture here, and I'm going to talk a little bit about the architecture of Kubernetes. So here are the key components. The first is pods. Okay, these are the smallest deployable units in Kubernetes. A pod can contain one or more containers. So it's essentially a wrapper for your containers. And then the level, I guess you could say, next to that, the level above that is the nodes. So the nodes are the machines, which could be virtual or physical. So that node we just looked at was a virtual machine that run your pods. So you could use a node as an entire server, but usually it's more resource efficient to use a virtual one. And then deployments is a higher level concept to manage your applications, and tells you how many copies of an application you want, and handles updates. So this is how we serve the application to the users. And replica sets are managed automatically by a deployment, make sure that the desired number of pods are running. And then services are used to expose your pods to other parts of your cluster and even externally. So we could serve the content on the pods as a web app to a client, for example. And so that's just a basic overview. And I want to give you all a quiz question based on this. Based on these components, which component do you think is responsible for replacing a failed pod? Okay, so let's say a pod were to crash, either through an error or overuse, or maybe the machine that it's hosting on is like heating up too much and it just shuts down. I'm putting up the architecture components again, and I want you to think about this a little bit. Try to come up with which one of these is responsible for replacing a failed pod automatically. Okay. Okay, so we have two answers. The first answer is nodes. We have two votes for nodes, actually, Sandra and Kitsune, because they're saying that they're the things that run your pods, which makes sense. But the other answer with 2 votes also, Jager and Sunny, but was replica sets. And that's actually the correct answer, because replica set is ensuring that the desired number of pods are running. So let's say one of your pods were to crash. replica set would automatically start a new one. Okay. Yeah, we can recount pretty easily. that's no problem. I'll do a little recount and get back to you. Okay. Yeah, good feedback from all of you. And so we got our answer to our quiz, and we're going to run a command in the terminal to see all the pods running in all namespaces. So this is very similar to the command we did before. We're going to do kubectl get pods, all namespaces. Oh, didn't spell all right there. All right, so this is actually quite a few more than we saw before, right? So we have DNS, which is a domain name server. So maybe that would be to communicate with, your domain. We have several others like API server, controller, manager, proxy, scheduler, storage, provisioner. So you can see there's a lot of different, namespaces for this, different components of your Kubernetes pods. So yeah, this is showing you basically the current state of your cluster. All right. And so why don't we, now that we've sort of looked at these pods, let's go ahead and cover a deployment. Okay. So this is this next level. If you remember, we've covered these basics. We can create a deployment that runs an Nginx web server. And I'm gonna walk you through this YAML file. Okay, remember, what the heck is a YAML? It's not a camel. It's a human readable data serialization language. Okay, so if you've ever heard of JSON, YAML would be a cousin to JSON file. And Kubernetes uses YAML files to describe objects like deployments and services, and we're going to get into that today. So the first thing we're going to do is create a file named nginx deployment.yaml, and we're going to do that in our VS Code. So let's open up that VS Code. See if I can get it open for us. And we have a question, actually. What's an Nginx? So Nginx is basically a web server software. So it's just a way to spin up a web server, like a website or some other blog or something like that. So you might want to serve a blog to your customers, for example, right? Okay, so I'm going to open up GHW March. Let's actually try that again. It seems like it didn't work very well. Yeah, like a something you would put on a server. That's right. Like live server. I suppose so. I've never used live server myself, but I'm sure it's similar. Yeah. Okay, so let's go ahead and have a new folder here. So we'll make a new folder for our Kubernetes fun. I'm just going to call it Kubernetes fun because why not? Oh. Okay, and maybe I'll actually open up that instead. Kubernetes fun. Okay. So we've got this going now. And we can check on this to confirm. what we're looking at. So we are going to add a new file called nginx deployment.yaml. And I have a few things for us to have here. So the first thing we're going to do is the API version tag. So all of these components are either keys or values. So it's like key value pair like JSON, but there's also levels as well. So we'll see how that works. But we're going to use apps/v1. So already GitHub Copilot knows where we're going. And we'll use kind deployment. And so this is how we specify that this is a deployment, and we're going to use the apps v1 API version, okay, for deploying that. And the next thing we're going to do is add some metadata. So we'll give our deployment a name, and we'll call it this nginx deployment. And we'll give it some labels that we can use when we do our services, like that the app is nginx. So, services is going to want to know that, right? Because it wants to know what kind of server architecture and formatting it's dealing with. And then the next thing we'll do is spec.replicas. So you remember we had that, so we don't want to do that. We want to do spec and then another level, replicas 2. Okay, so this is telling Kubernetes how many copies we want running. So we're saying, hey, we want 2 replicas, so that in case maybe one, let's say one were to crash, the other one would still be there, right? And so then we have our selector, and selector will tell Kubernetes how to identify the pods that belong to the deployment. So we can just use match labels, app nginx tier front end. This is the web server here. Template is where we can define the pod itself. So the template will have, for example, some metadata about the labels. Just like we did for the selector. And so then we will have a spec container, or a spec level here, just like we did for the metadata on our deployment itself. Okay, I'm just making sure that this matches my notes here. Okay, because sometimes I'll just replace this with latest. Sometimes it doesn't match your notes, and that's when it gets you into trouble. Okay, and so I had some environment variables too. I'm not sure if you all are familiar with these, but environment variables set the environment variables inside the container. So here we have a welcome message. So we could actually say that I'm going to replace this with welcome message, and I'm just going to say hello. Welcome to GHW, Global Hack Week. All right. And so that's how we give environmental variables. Does anybody know, why do we use environmental variables? Oh, sorry about that, Sandra. I'll make it a little bigger for you, and I'll share what we have so far in the chat so that you can check that. Remember, of course, the spacing is going to be a little bit different. So if you want to take a screenshot, go ahead and take a screenshot. But does anybody know why we set environment variables? I'll type that into the chat. Why do we set environment variables? Does anybody know? Okay. My most common use of environmental variables is for API keys. That's right. So API keys, for example, will tell you some secret information, right? Because oftentimes those are the keys that unlock your valuable money to buy more server resources or more API calls. So that's something we don't want to deploy, or just we don't want to send that out, distribute that to all of the people who might be working with our project. And all the people who might be viewing this stuff. And maybe so that every system uses the same stuff. This is actually another really good part, I think, to mention, which Jagar mentioned, which is that, it makes it standardized, right? So if you want to copy this whole code and you just want to change a few things that are germane to your system, all you need to do is go into the YAML and switch the environment variables. Right? Switch the API key to your API key, switch the directories to your directories, because once you do that, you can just do it once in the environmental variables, and then boom, it's done, right? So that's really good. Okay, so why don't we then continue on, and we will talk about, there's actually some more things we have to do here. We aren't finished. Sorry, I just got us on a tangent there. There's actually some more things, though, that we need to put in, just because we're really trying to get a lot of understanding here. So resources is specifying resource requests and limits, okay, so that Kubernetes knows how to schedule your pods, okay? So we'll give it a requests. So we're going to give a specific CPU requirement, a specific memory requirement, and we'll even give it some limits, okay? And so we'll use CPU 500M. Oh, I'm just going to use quotes here because that's what I used in my notes. And again, you never know. You never know what's going to happen with this stuff. So that's our resources. And then so just to explain this a little bit more, if you've never used this notation, then this is the minimum amount of resources that you would want for your pod. So you have 100 millicores. So that's 0.1 CPU cores. And then this is megabytes of memory, so 128 megabytes of memory. And the limit, right, so the most you could ever draw would be half of a core. So we're just saying, okay, if you need half a core, you can have it. And if you need 256 megabytes of memory, you can have that. But don't go past that. And maybe at that point, it might give us a warning error or trigger a crash or something like that, or reallocate somehow to another pod. I'm not sure. It would depend on how we built the system. But that's our resource requests and things like that. The next thing we're going to do is we're going to look at the readiness probe. Now, the readiness probe is a health check. It tells the Kubernetes pod when it's ready to serve traffic. So it tells Kubernetes when the pod is ready, basically. So we will put that on a get path and port 80. So all this information will be put out there on this path, on this endpoint, and we will have a delay and a period of updating so that it'll update every 10 seconds, and it's listening and it's communicating, with Kubernetes and telling it, hey, this is when it's ready to serve traffic, this pod. Okay, so Coventry has a really interesting summary here. Let's take a look and see how this is right, or whether this is right. So containers are the codes, dependencies, the easily portable thing. They're listed as pod namespaces. That's correct. And then pod is the smallest unit in Kubernetes cluster, like a wrapper for a node. That's also correct. And then the nodes are like individual computers. That's right. And in this case, these are virtual computers, the ones that we're talking about here. And so then replica sets, how many pods to run? That's right. Replica sets are essentially automating certain parts of the deployment, which is the manager of the whole thing, requires a YAML, define the environmental variables, and so far. So that's really a great summary there. Good job with that. And right now, what we're looking at is the communication between those components, which is as you mentioned, that's the deployment, right? So that's what we're looking at right now. For anybody who was confused about that, so really good summary on that. Thank you, Zelkova. So okay, let's continue then. So we'll continue with our YAML. We're almost done with everything. I mean, you might think, hey, are we ever going to finish this? Are we ever going to stop defining tags here? It is a lot, but now we're doing get liveness probe, excuse me. And this is essentially another health check, and it's telling Kubernetes when to restart a pod after it's been deemed unresponsive. So this is when, okay, so Kubernetes hasn't heard from this pod in a long time, right? It's been, the readiness probe is supposed to be telling it that it's ready, but it hasn't heard from it in a long time. And it's time to restart, right? So it's going to give some kind of initial delay. I'll just do 15 and 20 seconds. That's what I have in my notes here. And so those will be our liveness probe. Gotta say liveness probe, not live probe. Okay, so I hope this is indented right. That's why I'm so afraid I'm checking my notes all the time. Let's do one more check before we continue because, yeah, I do not want to mess up and have some problem down the line. Let's see here. Let's just use it as one more good way to check all your notes. And you can see it in the chat. I just pasted the entire message here. You can also take a screenshot these days. And if you take a screenshot of text, your Mac, probably your Windows computer too, is really good at extracting the text from that. You just highlight the text and it'll work right away, especially on something like code, which is really uniform in its formatting and things like that. So feel free to grab a screenshot too if that's what you want to do. See here, container port 80, name welcome message, welcome to Global Hack Week, resources. It's looking good to me. I think we're well on our way now with this YAML file. So the next thing to do is I have some challenges that you could try out, like customizing your YAML file. So try changing the number of replicas from 2 to 3, for example, if you want. Or you could try to update the value of welcome message to whatever you want. You know, I have high Global Hack Week, but you could put something else. And just make sure you save your file after you're done updating that YAML file, okay? So the next thing to do is to apply the deployment, okay? So we're going to use our command line for that. And I'll show you where we are right now with this. Just going to get into my Global Hack Week Cloud folder. Okay, just need to check and make sure I know where the thing is. All right, I can just use my Visual Studio Code actually. Should be able to. So what I'm going to do is use this command, kubectl apply -f, and then we'll do our nginx deployment. And I'm going to paste that command in the chat as well, so you all can take a look for yourselves how this is going to work. I wonder what that problem might be. We might have the wrong command here. I knew it was too good to be true that the levels would be right. Okay, here's our problem maybe. The template could be wrong. I think that's the problem. In fact, maybe everything after match labels is wrong. This is why I don't like the, I'm not a huge fan of YAML because of this exact problem. But let's see, this might be a little bit better because now these are on the same level. Okay, that worked. All right, so it's because the selector and template were not on the same level. So now I'm really gonna drill this into all of your heads and make sure your levels are right. So I'm just gonna put 1 through 30 here, and then I'm gonna move to the next. If you want to take screenshots and try to line up yours with this example, here's the next bit here, 45, 18 to 45, let's say, so that you can make sure that your levels are right. So did anybody else have an issue getting their deployment done here, created? And so, now that we're in our terminal, let me get my terminal back. So we did that command, it worked. And just to verify that it worked, there's a few other commands we could try, like get deployments. So I'll type that into the chat as well for you. So if this worked for you, that's a command that we can now do that we couldn't do before, right? And you can notice that the name here is nginx-deployment. Well, what did we ask it to name it? nginx-deployment, right? So that's why these YAML files are so great, because they can really contain a lot of information that is then going to automate a lot of this stuff for you. Okay, so we applied our deployment. That's really great news. And the next thing we're going to do is a quiz. So first, let's ask, okay, which field in the YAML file sets the number of pods to be created? Which field in the YAML file sets the number of pods to be created? Why don't you type your answer in the chat of what you think that is? Okay, Jager says replicas. Replicas would be the right answer. Okay, so if you recall, if you go back to our code, we used that in line number 8 here. We used replicas to basically say we wanted 2. And we could also change it to 3 and save. And the way we would then update it is by, oh, sorry, I guess I need to get my deploy back to apply this deployment again. And now it's configured again. Okay. So if we were to type now kubectl get deployments, look at that. 3, right? So that's great. Okay, so let's go back to our slides now, and we'll talk about service, okay? Creating services. So if you remember, services is how we expose our cluster to resources outside of the cluster. So we're going to want to expose this deployment, now that it's running, to access the Nginx web server from outside the cluster. So we do this using a Kubernetes service. And so I'm going to talk a little bit about service now. And so I'll show the file, YAML file for the service. I want you to create a file called nginxservice.yaml. And these are the different things that you'll do. Okay, so first we're going to have just to call out the overall highlights, and then we'll dive deep into it. It's the same things we had before with API version and kind. With metadata, it'll be a service named Nginx service. We will have spec selector, spec ports, and spec type. All right, so let's go into our, and you have these in the slides if you want to take a look at them and you just forget, but we'll go over it ourselves too as we're going along. So let's type nginx service.yaml. Okay, and so that first thing we type is our API version. And this is kind service. So if you remember before, we did kind deployment. It's a little bit different now. So it's telling Kubernetes what kind of YAML file this is, what kind of configuration file this is. And so for our metadata, you'll remember the metadata is telling us, how to name the service. So we'll call it Nginx service because that's what we're using right now. And we can use annotations as well, which is what that note was telling us. So we can use Kubernetes demo. And in our spec, so these are our specifications here, we have our selector. So we had this in the previous file too, but we're going a little more in detail now. It tells the service which pods to target by matching the labels. So let's take a look. Nginx tier front end. Let's take a look at our deployment YAML, and you'll see we have the exact same labels to select, okay? So that's really important. It's basically matching up these things, all right? We didn't need to specify the number of pods because this is not a deployment, this is a service. And then we'll, of course, have our ports. So we have TCP protocol, which is just basically one of the many protocols that you can have. HTTP would be another example of a protocol. Port 80, we'll just have port 80 for listening and sending traffic on the target port. And then type, we're going to use node port, which makes the service accessible on a port on each node, okay? So that means that you could access this service through any of our nodes. That's exactly what we want for this file. All right, Zelkova is headed out. Thanks, good night. Hope you had a good experience and a good sleep. Okay, so now we will move on and we'll apply it. We'll apply what we're learning. So let's open our editor and apply the service. So first, yeah, and let me know how it goes in the chat. Don't be afraid to tell us what's happening on your end. I know it's kind of late for some of you, so definitely feel free to log off if you want and watch later. That's totally fine. So, okay, there's the line apply f nginx service.yaml, and I'm going to do that in my code editor. So we have our terminal, type paste, and we just run that. And we get back service created. So that means we're doing something right. And then we will run our kubectl get svc. And that is going to show us our new service. So you can see this great stuff here, node port and our cluster IP. Okay. So I want you now to answer this quiz for me. What does the selector field in the server's YAML do? So does every Nginx thing will have a deployment and a service YAML? Yes, you must have that for this Kubernetes configuration. You could not do this without a service and deployment. That's a very good question. You could just do a traditional Nginx web server. You don't need to use Kubernetes for this. But if you want to, have load balancing and have some of these advanced configurations where you're only dedicating a fraction of your compute to serving the web server and things like that, then yeah, you're going to want to use deployment and service because you're going to want to use Kubernetes. It's a really good question, though. Does anyone know, though, what does the selector field in the service YAML do? I'll give you a hint. We talked about it a little bit here. I'll give you a hint. So in the selector, you notice it looks exactly the same as it did for our deployment. And there's a field here called match labels. Isn't that interesting? Match labels. Wonder what that could mean. Anyone want to guess what the purpose of selector is here? All right, well, I'll just tell you, it's telling the service which pods to target. So you might have many different pods. You don't need to only have, not every pod needs to have hosting, some IP to host. You could have a pod that has your database in it, and that's totally acceptable. Or some other application running, frankly. And maybe you don't want your client to access that part of it. So that's what the selector does. It selects which pods to serve. Yeah, so excellent. And now we'll try modifying the service type. So I want you to try to change type node port to type cluster IP, and then try to reapply. So give me, I'll give you about 1 minute or maybe even 30 seconds to try this out. All right, so if you had a second to do this, I'll just explain to you how the external port details will change. So first we had the following, right? You can see that the external port looks like this, node port. Now, if we change this to cluster IP, we save, we rerun, reapply our service, rerun, you can see now the type is cluster IP. All right. And what this means is that the service is now internal. Okay. So it means that this is only if two services need to talk to each other. Like, for example, you could have a database that needs to talk to a front end. That would be cluster IP. But if you are trying to have a web server where you want to serve content to others, you want to probably use node port. So we'll save that and we'll keep it that way. All right. So yeah, let's talk a little bit about scaling, rolling updates, and health checks. So first, we're going to talk about scaling, okay? And it helps you change the number of pods running on your application on the fly. So instead of going back into our YAML file, we can just use a command in the terminal. So we're going to use kubectl scale, and that's the scale command. And we're going to type in our deployment name, which is nginx deployment. And then we'll type in replicas equals 4. And that should set the pods to have 4 replicas. So let's try that out. So we'll go to our terminal and we'll type in the paste here, enter that. And it says, oh, it's been scaled. And to test it out, remember, we can actually type kubectl get pods. So that's exactly what we'll do. Kubectl get pods. And there we go. You see all 4 pods running now. Okay. And another thing we can do is rolling updates. So that means it allows you to update your pods gradually. So, like, for example, if you had okay, let me pull. Actually, my next slide is an example. If you wanted to change the image version of your nginx container, so what I mean by that is, let's say your nginx is updated, right? They made a new version of nginx, and you want to update to that. Well, normally, if you didn't have pods like this, you would have to shut down your web server, right? You would have an outage then, because your users would not be able to access your web server. And then you would reboot it, right, with the new nginx, and then you would have to return on the computer. So with this, we can actually roll this out one by one and have no outage. So if all goes to plan, right? So the first command there was kubectl apply -f nginx deployment YAML. Now, what we're going to do is actually go into this deployment YAML, and as it said in the slides, change from nginx latest to nginx 1.19. So you could change from whatever version you currently have, right? And then we will type this command, the one I put in the chat there. So we'll do kubectl apply -f nginx deployment.yaml and run. So we can monitor the update, as I mentioned. I think it's probably already done, to be honest, but let's see if we can catch it. Oh, there it is. So it's actually done only one of them so far. So here's the command in the chat. You can watch yours update too. There it goes. It did 2 now. 2 out of 3. That's pretty good. So it has to go to each of these pods one by one and change and update them, essentially. Come on, 3. Let's see 3. It's taken quite a while. Let's go back to our slides here, and we can move on and check up on it in a little bit. So once our update is complete, we can simulate a rollback. Okay, so this is just like basically the opposite of a rollout, right? So okay, it's the command kubectl rollout undo, and we can undo what we just did. So we just made an update to the Nginx deployment. So this will just do the reverse of that. So let's try typing that into our chat, our terminal, because we do have it finally done, rolling out. So we'll do undo. And so it's rolled back our thing. And we can use kubectl rollout status to check on this, just like we did before. Same command. I typed it in again, though, just for you to have. You can watch it roll back, that change. I wonder if Kubernetes is mad at us because we we just updated the version only to instantly change it back without doing anything. Hopefully it'll forgive us for learning. Okay, so while that's working, we're going to continue along, chug along here. Next thing we want to try is health checks. So health checks can ensure that your pods are functioning correctly. Okay, so we've already defined readiness and liveness probes in our YAML. So we can now review them a little bit. So let's type in our terminal to describe a pod. Okay, so describe will tell, like we said, about our health checks. So I wrote pod name here just as a placeholder, because your pods are going to be named differently than mine. Kubernetes uses random strings to ID these pods. So you're going to need to go in and type kubectl get pods to get your pod names. So we'll type that kubectl get pods. And let's see, here's one of my names here. Look at that big name, goodness gracious. And we'll type bash, or not bash, sorry. I don't think you need bash. I think I might have just copied that from my terminal. And so I did that, and it tells me a little bit about my my pod. Okay, so you can see its liveness. So it had 1 success, 3 failures. Readiness, 1 success, 3 failures. And you can see all the conditions here. So is the pod ready? Are the containers ready? Is the pod scheduled? Things like that. And to be frank, I don't even understand all of the different outputs here. But if you want to research one of them, that could be a great activity to try and research one of these fields and figure out what it means. But that's just going to tell you everything about your pod's health. Okay, and then we can move on to advanced customizations, where we're going to add configuration data to our application using config maps, which allow you to decouple configuration from your container images. And I'll talk a little bit about what that means in a minute. Okay. So we're going to make a new file called configmap.yaml. Let's do that here. And we're going to give it a lot of the same tags that we did before. Of course, this is going to have the config map kind, metadata. We can call it our Nginx config to distinguish it from the other things we've been doing. And we're going to give it some data. Okay, and so for example, we're going to give it an index.html. Who here has heard of index.html? I think maybe a lot of you have. basically this is a layout format for making a website. I love the autocomplete. So easy to use that. Okay, so this should work. Wonder if I have the wrong slash here, maybe? I think I might. Yeah, it should be a pipe, I think. So just keep that in mind as you go through here, that this is the correct way. And I'll paste it in here. Okay. See you next time, Jager. Good to see you and good to join. Yeah, this stuff can be a little bit confusing, but we're going to keep going over it in the next couple parts. We're going to come back to a lot of these concepts and keep building on these concepts, so don't worry if it seems a little intimidating at first. Okay, and so we're going to now apply this config map using the command. I'll put it in here. So kubectl apply -f config map.yaml. And so this config map will store a custom HTML file. Okay, you can see that from the YAML. So we type kubectl apply -f config map. Oh, sorry, I used YML, not YAML. All right. Always having a problem with this type of stuff. I wonder where my colon is missing. It says I'm missing something. Kind of noticed that, honestly. I'm just going to copy it straight from my slide. Okay, it must have been the fact that there's a space here, maybe. Oh, and maybe this should also be tabbed. Yeah, that's the thing about YAML files, is the spacing is so important. So let's try saving that and doing it again. I wonder what this issue is here. Let's try our trusty Copilot and see if it will fix it if we ask it to. All right, maybe that fixed the problem. Click save. It did. Great. So Copilot knew that we needed to fix the name. I must have just typed in the name wrong, I guess. That's okay. So we got our config file created and applied. And we can update our deployment YAML to mount this config map to a volume, as a volume. So let's actually look at that in our slides. We can see under the container definition, we're going to add a volume mount section, and under the pod spec section, we're going to add a volume section as well. So let's actually go into there and take that apart a little bit. So we're going to go to the Nginx deployment here, and where we see spec, we're going to change a little bit here the fields. And we're going to put volume mounts here, and we'll put the name. So we'll just put, I'm just going to put config-volume. And that mount path is correct. That's just where we're mounting this volume. And then we're going to actually have a volumes section too, which will have its own name, config-volume, and its own config map. Okay. So now we can save all this, which we did. And we will, of course, update our deployment. And you might remember how to do this. We do kubectl apply nginx deployment.yaml. Once again, we're having a trouble here. I wonder if our trusty fix will help us. A lot of the times our fix can help us adjust the spacing. Okay, and it's configured now. So that's really good. And so the purpose of the config map is a way to inject configuration data into these pods without baking it into the container image. So we can actually put this configuration data in without just to any pod we want, right? And so let's look at the next slide here. Let's try adding an environment variable from your config map into your container. Okay, and so we will modify the container spec to add an environment variable that references a key from your config map using the value from field. Okay, so we can get this from the config map. So let's go to our container spec. All right, and we have already in our spec env welcome message, and we gave it a value. But imagine we could have a ton of different deployments here. We might not want to put that information in each deployment, so we can get the value from. Okay, so we'll just rewrite this to say value from. We'll put config map key ref nginx config index.html. Okay. So now it's going to get from our config file the index.html and use that as the welcome message. All right. And if you remember, our index.html has this great HTML message, welcome to advanced Kubernetes deployment. Okay. So that's just giving you a sense of what the config map is. And to reapply the YAML, you remember the code. You must remember the code. We've done it maybe 3 or 4 times now to update these to reapply these YAMLs for deployment purpose. We just use kubectl apply, right? And we apply to deployment. And so now that that's set up, oh, we actually have a problem. Let me just quickly fix that. Now that that's set up, we can use describe pod. So let's check that. Describe pod, and oh, I want to get the pod names again. I forget what they are. Okay, so kubectl describe pod, and I will describe this first pod. Okay. So we can take a look at this. And we can see its welcome message. It's set to the key index.html. Right? So that's pretty solid, pretty good. And the next thing we're going to check out is customizing services and exposure options. So this is how we can customize our service to change how the application is exposed. So open up your nginx service YAML again, and we're going to change this service type from node port to load balancer. Does anybody know what load balancer is? Not sure if your environment will support it on this local computer, but we can try it. If anybody remembers what load balancer is, we're just going in here and we're saying type load balancer. So load balancer is a way to distribute the resources so that they are used appropriately when you have a lot of demand on your server. So we can now type something like kubectl fngservice.yaml, and we can do our serve get svc, just like we did before, and you can see our load balancer has applied. So we will do our next slide here, which we'll skip the quiz because we want to get to more things here. We'll take a look at one more advanced concept before we log off, which is to create a horizontal pod autoscaler. Okay, and so to do this, it's going to basically automatically scale based on CPU usage. So if the CPU usage goes above 50%, you can see this command here, then it will increase the pods to the point that the CPUs are not being used that much. So this is a really cool thing, right? I mean, if your CPU is getting 100% usage, obviously it's going to be really slow service. So this is just to keep the application really snappy for whoever's using them. So we can track that out. We can use kubectl, and we'll use this command. So I'll paste the command as well in the chat. And we've got our auto scale, and we can try this to get the HPA. And you can see it's telling us, how much of these we are allowed. So between 2 and 10, and it's telling us our CPU target. So how much CPU usage we would be using if this was actually being served. So those are our slides here. And let me just finish by saying thank you. And stay tuned next time for part 2. We're going to continue along with our Kubernetes. We might use the quiz. We had a quiz, but I think a lot of people had to log off because it's a little bit late. So we'll save that maybe for part 2. And that will be pretty soon. It's in the schedule. But what I want you to remember is that Quinn's stream is next. It's building a serverless Discord bot using AWS Lambda. And that's going to be from 4 to 6 a.m. Eastern time. So if you're interested in serverless, we did talk about serverless this morning. This would be a great application for that and a way to reinforce your learning about serverless. Okay. So yeah, hope you all enjoyed the stream, and thank you so much for joining. And next time I will do cloud storage and databases 101. So I hope you can all join for that too. All right, I'll see you all later. Bye-bye.
lonely boy.